Hello, students. I hope you are having a very good day. And I'm your faculty for robotics. So let us begin to make your good day a better one. Let us begin with our new session. Here it is. So, session 18. Okay, let us begin with, let us see what new we are going to study today in our this session. Operators. Now, the operators, they are basically used in Arduino programming from basics to advanced levels. Okay. Now, what are they? We'll be getting into the nitty-gritties and the depth of it. Now, it plays a crucial role. Why? Because in every programming concept like C, C++, Java, and etc. Okay, the operators, they are basically used to solve logical and mathematical problems. Okay, so operators, you all know from mathematics, you all have done previously, you all have used them. Okay, so those are only the operators. Okay, and like in every mathematical operation, okay, the name operator has come from the operation, like what operation we are performing, which operation we want to perform. Okay, from that the name has come, right? To see the types of operators, they can be classified in Arduino. Basically, we'll be focusing on Arduino. So in Arduino, it can be classified into these types. Number one is the arithmetic operator. Number two is the compound operator. Number three is the Boolean operator. Number four is the comparison operator. And number five, bitwise operators. Okay, let us see all of them, and let us, of course, let us focus on the programming or coding examples, okay, which we are focusing on from our first class itself. Now, arithmetic operator. Now, arithmetic operator are, I should say, the most common and most widely used, most easily understandable operator is the arithmetic operator to your students, because you see there are basically six operators that we use. So it's a very general concept because we all are familiar with mathematics, and this arithmetic operator is basically the mathematical operators only. Okay, there are one or two differences that I'll be telling you right now, and you need to remember it or you can note it down specifically. See, at first there is the equal to operator, or we call the assignment operator. Now remember, dear students, in our previous session, I basically taught you about the assignment, right? How to assign a value to a certain variable or a data type, right? There also, if you remember, we use the equal to sign, right? This sign, this equal to sign we use there. Okay. All right. Now, this is the assignment operator. So that means by using this, what we are doing is we are basically assigning something, right? Okay. Now, the assignment operator in Arduino is used to set the variable value. It is quite different from the equal symbol normally used in mathematics. Okay, why? Because in mathematics, for example, we write 5 plus 5 equal to 10, or 3 plus 4 equal to 7. So in there, we use this equal to sign to to define that this is the value, this is the result. But here what we are doing is we are basically assigning a particular value to a data type, and that is why the name has come to be assignment operator and not equal. The second one is the addition operator. Now, this I believe I don't have to explain you much, because this is what the plus sign is, additional operator. For example, p plus q, a plus b, x plus y, anything we can perform. All the additional operations we can perform using this sign. Of course, we know from our childhood, from nursery itself, right? And then comes subtraction. Similar, very common, we know. Okay. Multiplication, we use this asterisk or star symbol, okay, for multiplication. This is also very common. Now, the next two are very important to remember, very important to notice, dear students. Try to understand. The slash symbol over here that we generally use in mathematics also as a division symbol. Okay, so this division is used to determine the result of one number divided with another. Okay, for example, a divided by b, p divided by q, anything, x divided by y. Then what is the modulo operator does? That is the percentage sign. The modulo operator. The modulo operator is used to calculate the remainder after the division of one number by another number. Okay, I'll show you the result so you'll be understanding the basic thing. So if we want to if we want to calculate or show or print that or display the remainder of any division operation, then we use this percentage sign. So if I write a divided by b, it will be general in general a divided by b. But if you write a percentage d, okay, so it will be giving the output, giving the result or displaying the result. What it will display? The remainder of a divided by b. Okay, so that's about the modulo operator. Let's move further. This example is basically a very simple example just to show you the operation of what we are using. Okay, so 5 plus 2, we all know the answer would be 7. Okay, I believe we all know that, right? So see what we have done over here. We have declared the variable like int b. Okay, and then we have in the void setup we have set the rate. We don't need to declare or set up many things over here because it's a very simple beginner operation, right? So in void loop, we have written that b, that is the integer that we have developed, okay, or declared at first, okay, as a variable, right? So b equal to 5 plus 2. And then we'll be printing that is serial.println b. So what output we'll get? As you can see, we'll be getting the output as 7 because 5 plus 2 is 7. So 7 is assigned to b. Okay. You see, we have used two operators. Try to understand what I'm trying to make you understand. 5 plus 2, 7, we all know, right? What I'm trying to make you understand is that we have used two operators. One is the assignment operator, that is equal to sign. One is the addition operator. What is the purpose of the addition operator, dear students? To add, right? To sum up the thing, that is 5 plus 2, that is 7. Now, b is, we are printing b, and how b is getting assigned the value of 7? Because we have used the equal to operator. Understood? So two operators in the same example I have shown. Okay, let us move further. And in this one, what we have done, we have basically again declared a variable that is int d. Okay, then in void setup, we have again declared the rate, that is the serial rate. And then in loop, what we have done, for d, we have assigned the value of 5 minus 2, right? Okay, and then we have printed d. Okay, so at first, for the serial.println d, for this first print command, what we will get? We will get 5 minus 2, that is 3. Okay, 3 will be printed. Again, after that, in the next line, we have d equal to d plus 3. So now the value of d is being incremented by 3. So again, 3 plus 3, we will be getting 6. So the output would be 3 and 6 in the next line. Understood? Okay, this is how we can play with operators. Right? See, this is the whole process flow. You see the output is written over here. Output is 3 and 6, right? And this is the whole process, right? First, what we have done, d equal to 5 minus 2. So we get, if we print by using the command serial.println d, we get 3 as the output. Fine, good enough. Okay. Now again, we have incremented the value of d to be d plus 3. That means the new value of d, this command means what? This command means the new value of d is nothing but the old value of d incremented by 3. Okay. This is what we have done. Understood? Next. Similarly, what we can do is we can perform multiplication, modulo, and division, and the int variable will store the integer values. Okay, that's why we are using it. For example, 20 divided by 3, we get 6. Why? Why we are getting 6? Try to understand. Because int value will only give the first integer to be printed. Okay, if we would have taken float in itself, then we would have got the decimal value. See, decimal value is used to force the compiler to print decimal value. Why we are using 20.0? Because since we have taken int, if we wouldn't have taken 20.0, this value, this output value in decimal format wouldn't have been printed. Understood? Okay. If you have just written 20 divided by 3, it would only have printed 6. Since we are using int and we are using 20.0, that's why the output is being given as 6.66. If you don't want to use this kind of thing, only 20 divided by 3 you want to write, then you must not use the int. See, order of mathematical operations. Let's understand the order of operations considered by the Arduino while performing calculations. Okay. All right. First, parenthesis, then multiplication, division, and modulo, and then addition and subtraction. So if there are multiple operations next to each other, they will be computed from left to right. Try to understand. Okay. This is the what to call it as a system, you can say. Okay. This is the system by which it is operating. Okay. Next. Now here we have again declared the integer as C. Okay. And then what operation we have undergone? C to be assigned as 2 multiplied by 3 divided by, again in parenthesis, that is the bracket, 2 plus 1, again plus 4. The output typically comes out to be 6. How the output is 6? As I said in the previous slide, try to concentrate over the order in which the operations are performed, right? First, in parenthesis, it will be performed like, for example, 2 plus 1 will be 3 at first. After that, the multiplication and division would be performed, like 3 multiplied by 2, it will be 6. And hence 6 divided by 3, we get 2. After that, only one operation is remaining, 2 plus 4, that is 6. So this is how the operation is being performed. See, that is what is being demonstrated in this image. I told you previously, people who will find it difficult to understand, for them, I have provided images. Okay, so these pictures are from real time. The outputs are basically from real time Arduino IDE when I have performed them. And these images are basically I've made for your convenience. Okay, this is the order in which the operations are being performed, be it any code in Arduino. Okay, this will be definitely the order. Understood? I hope you have understood the order of it. Now, compound operators. What do you mean by compound operators? Very, very important. Very important. The I should say the most crucial part in the programming section. Okay. So the compound operators perform 2 or more calculations at once. Okay. So what we are doing, we are performing more than 2, okay, or 2 or more than 2 operations. We are performing them at once. The result of the right operand is assigned to the left operand, as already discussed above. That means in the previous slide. The same condition will apply to all the compound operators which are listed below. So, for example, A and B are 2 variables. Now, at first, B++. What is B++? Okay, you have heard of C++, right? So, like that, C plus 1, it is C++. So, similar to that, B plus 1 is B++. Okay, so this B++ operator, okay, any variable and plus plus operator, it's basically called the increment operator. Okay, what do you mean by increment operator? The value that is being assigned over here, okay, or the value that is being assigned to the variable over there, A, B, C, D, X, Y, anything, it is incremented. The value is incremented by a value of 1. Okay, so plus plus means plus 1. All right. Now B plus equal to, that means if we write B plus equal to 4, that means what we are trying to say? We're trying to say that the value of B itself is being increased by 4 in the next step. That is B is equal to B plus. For example, if we have taken B equal to 2, so if we write B plus equal to 4, That means now the value of B will be printed as 2 plus 4, that is 6. Hope you had understood this. Now comes B minus minus. Okay, the B dash dash. So B dash dash again, like B plus plus, it is B minus 1. It is called the decrement operator. Of course, the opposite of increment operator. So you see, the decrement operator is basically like just opposite to the B plus plus. Similarly, B plus minus, B plus equal to, we have the opposite as B minus equal to. That means it will be, if we write it B minus equal to 3, what we are doing is we are decrementing the value. Okay, by that now. All right. Now B star equal to, again, same. If we multiply the same number with the given number, we'll be getting the answer for it. Okay. So these are basically, dear students, the compound operators, and try to understand, try to remember, these are the most important things when it comes to mathematical operation or even general code. Okay, let us move forward. B slash equal to. So it's for the divide part, for the division part. If we write B slash equal to 5, it means B now is being added, assigned the value of B divided by 5. And if we write B modulo equal to, or B percentage equal to, whatever you say, it basically it is called modulo operator. So B modulo equal to 2, it means now the value of B is assigned as B modulo operator 2. Okay, that means the remainder will be printed over there. Okay. All right. So we can use it with two variables, right? As I have mentioned below, see, B plus equal to C, that is B equal to B plus C. B minus equal to C, that is B equal to B minus C. So two variables are being used over here. Now we can use both of them in our programming. In between B or C, we can use both of them. Okay. So there are two variables too. Understood? Next, the Boolean operator. So the Boolean operators are not the there are the not operator, okay, which is used as an exclamation sign, okay, logical and, right, the double and sign, okay, ampersand sign twice, logical or, okay, that is the straight lines twice, okay. So these are the operators that are being used in the Boolean operator. Now, Boolean operator, to understand it, first of all, you need to know what Boolean algebra is. Okay, so it's basically a branch where it's basically a branch of algebra that deals with electronics. Okay, and we have gates, logic gates over there, and there are few rules that you need to remember, and you can perform operations in Boolean algebra. Okay, it's very interesting and very easy to understand actually. If you practice it, then you can perform operations, okay, complex operations also. But here we are not here to study Boolean algebra in details. Okay, so just basic concepts. There are AND gate, NOT gate, OR gate. All these gates are there. Then you can combine those gates and form the NAND gates, NOR gates, like this. Okay, so you see those operations can be performed. For example, AND can be performed, AND operation, by using this sign. So ampersand sign twice, if you use it, it denotes the AND operator. So the result of the condition is true if both the operands in the condition are true. That means if we consider the below example, if A equal to B and B equal to C, that means in this statement, what is being done? This statement is true if both conditions are true. That's what AND means, right? If I say that this food item is both sweet and sour, right? So that means both conditions are true. This is sweet also, and this is sour also. Okay, so there in that case we can use this AND operator, right? So if A equal to B and B equal to C, then only this condition is true, right? And OR is the opposite. OR means either this or that, right? That's what the literal meaning of OR is. Okay, the result of the condition is true if either of the variables in the condition is true. That means if A greater than 0 or B greater than 0, like that we spell it. Okay, like that we pronounce it. All right. So the above statement is true if either of the above conditions is true, right? Then comes the not operator. All right. It is used to reverse the logical state of the operand. What does that mean? For example, A not equal to B. Try to understand. What we are doing, we are negating the fact that A not equal to B. Then only the following operation can happen. Like that we are using. Okay. So the not operator returns the value 1 or true when the specified operand is false, because since it is the not operator, so only it will operate if the condition is false. Now it also reverses the value of the specified expression. I hope all the Boolean operators are clear by now. Okay. Let us move further. Comparison operators. Very easy. These are very easy actually. What we are doing, what operations we perform, we are studying that only by using what symbols, which symbols. The comparison operators are used to compare the value of one variable with the other, right? The comparison operators, they are listed below. You see less than, greater than operators, right? Those are the comparison operators. So either this quantity is greater than this quantity or this quantity is less than this quantity. Like that, it is being used. In general terms also, we use it like that on. Series code, series code programming. It's a good example containing many operators. See, int b and int c we have declared these two variables to be integer, right? Now in word setup, we are declaring the rate, and now we are assigning b equal to 3 and c equal to 5. Now, what is the condition that we are assigning to it, dear students? See very closely. If b less than 4, then we need to print b. If c less than 4, we need to print c. Now, we are using the comparison operator here, right? If b we have assigned to be 3, right? So 3 is less than 4, so 3 will be printed, right? But c we have assigned it to be 5. So is 5 less than 4, dear students? Of course not. We know general knowledge, right? So this will not be printed. Understood? So you see the output, only 3 is printed. If c would have been any number, for example, 1, 2, 3, or 0, right? Then it would also have been printed, since those numbers would have been less than 4. Understood? This is how the comparison operators, they are being used in real time. See, greater than, okay, less than 1, then greater than. The less than operator checks that the value of the left side of a statement is greater than the right side of the statement. We know we have used it in the very similar manner in mathematics also. Oh, okay, so this must be very clear to you. All right. Okay. Now the equal to operator. It checks the value of two operands. That means if the values are equal, the condition is satisfied. And try to understand this. Previously, let me show you. Previously, we have one operator called the assignment operator. It is a single equal. Assignment operator, what is this? How we are using it? We are just assigning a value. For example, b equal to 5. That means for this case only, we have assigned b, the variable b, to be the value 5. So this is the assignment operator, single equal. Now what we are studying right now, see, double equal. That is actually the equal to operator. We write single equal to in mathematics for equal to operator. Here in coding, in programming languages in Arduino, we write this double equal to be actually equal to it. Like if this value is equal to this value. Okay. That is the case. You need to remember this. Okay. Don't get mixed up between the assignment operator and the equal to operator actually. Not equal to operator. See, not equal to operator, the exclamation sign refers to the not sign, and equal to is equal to, So exclamation and equal to sign denotes the not equal to operator. So not equal to operator, you see, if only the condition is false, it will be operating. For example, if A not equal to B, so that means only it will operate the further code if only A is not equal to B. If we find out A to be equal to B, the code will not be executed. That's it. Okay. Now again, if we are combining two operators like less than equal, the less than equal to, that operator checks that the value of the left side of a statement is less than or equal to the value on the right side, right? That's the general purpose what we use this operator in mathematics, right? In maths we use this kind of operator, less than equal to, in inequalities chapter, if you remember, right? The statement is true if either of the condition is satisfied. Okay, that means this can be a question, right? So what if any one of the condition is satisfied? The statement will be true. So if it is either less than or equal to anything or both conditions are satisfied, then the statement will be. I hope you've understood this. Then again, the opposite of it, or somewhat its partner in prime, for the greater than equal to operator. So either the quantity in the left side should be greater than the quantity in the right side, or the quantity in the left side should be equal to the quantity in the right side. Either this or that, anything would work, and the condition will become true. I hope this concept is clear to you. Next, bitwise operators. Now, the bitwise operators, they operate at the binary level, right? These operators are quite easy to use. How? Now, there are various bitwise operators, like some of the popular operators are listed below, which I have listed over here. Bitwise not. You see this symbol, right? Similar to symbol. The bitwise not operator acts as a complement for reversing the bits. That means, for example, if b equal to 1, see, we are assigning a value. This is the assignment operator, right? B equal to 1. The not operator will make the value of B equal to 0. Clear? Okay. See, if we are giving an input 0011, so the output gets reversed. It becomes 1100, right? That is the purpose of the not operator. Not function in electronics or computer science, not means the opposite. So in case of a binary system, where only two variable, like two numbers we use, like the binary system, that is 0 and 1, right? Or 1 or 0, 1 and 0. So if we are giving an input of 1 and using the not operator, of course, we will be receiving 0 as the output, and vice versa. If we are giving 0 as the input and we're using the not operator, we will be getting 1 as the output. I hope it is clear to everybody. Then comes bitwise XOR. Okay, XOR, or you can say pronounce it as XOR. Okay, this is the simple upper side arrow. The output is 0 if both the inputs are same, and it is 1 if the two input bits are different. That means 1001 input 1 or operand 1, 0101 input 2, 1100 output, result is XOR we are getting. See? Okay. So we are performing the OR operation along with X, right? Okay. See? 1 and 0, OR operation gives 1, 0 and 1, 1, 0, 0, 0, 1, 1, 0, right? Understood? This would have been very easy if for people who have already gone through Boolean algebra, right? Next, bitwise OR operator. Notice the symbol, okay? So the output is 0 if both the inputs in the OR operation are 0. Otherwise, the output is always 1. Okay, see this. In this case, in the third digit, both the numbers are 0, so it will be 0. Understood? Simple Boolean operations which we are performing using the programming language. Now, bitwise AND. This is the symbol. The output is 1 if both the inputs in the AND operation are 1. So you see, only if both the inputs are 1, we get the output to be 1. Otherwise, if both the inputs are 1 and 0, 0 and 1, or both are 0, we will obviously get 0. Simple Boolean algebra. Now, bitwise left shift and bitwise right shift. The left operator is shifted by the number of bits defined by the right operator, right? So A, this symbol B. That means A will be shifted by B number, okay? And bitwise right shift, again, it will be shifted to the right. This the direction changes there. I hope you have understood this, okay? Too many operators I've discussed in today's session, okay? And I hope uh, all of you have like gone thoroughly through this operator class, okay? Very, very important class or session, dear students, because you see in the most of the times what we'll be performing are the arithmetic operations, okay? By programming, by coding, by doing, making, giving the intent of the code, okay? So I hope you have enjoyed the session. I have enjoyed it thoroughly. This was a very important and somewhat long session than others. Okay. I try to keep the sessions also short so that you don't get feel bored in between. I hope you didn't feel bored because it was a very interesting and very important session in itself. Okay. Thank you very much. Thank you for being so patient. Okay. So I'll take your leave right now and we'll see you again. Again, we'll meet definitely in the next session. That's it for today.